Okay, welcome back. And now in terms of looking at this, we're going to use Kramer, but that also entails determinants. So Wronskian will be involved. And U sub 1 prime will equal Wronskian sub 1 over Wronskian, or W sub 1 over W, which equals negative Y sub 2 f of x over W. And U sub 2 prime is W sub 2 over W, which is Y sub 1 f of x over W. Okay, where W is the determinant of Y sub 1 prime, Y sub 2 prime, W sub 1, I should say, is the determinant of, so in Kramer's rule, you take the first column, and in this case, we're going to replace it with 0 and f of x, all right? From the first video, those were really the two solutions. Remember when we did that, that final work on understanding variation of parameters, and I said set the one equal to 0, set the other equal to f of x. So go back and look at video 1. But we replace that there, and then we have Y sub 2 prime. And then for W sub 2, we keep the first column the same as our W, as our Wronskians, and then we replace the second column with 0 f of x, okay? And then once we do that, then find U sub 1 and U sub 2 by integration. And again, since we're talking about a particular solution, when you're integrating, you don't need to include a c. You can just assume the c will go to 0. Okay, the constant of integration when you're doing your particular solution. Remember your particular solution, which is what we're looking for. All right, let's do, I think, one example because it's going to be thorough. I think one example will be enough. If not, then in class, you can ask me to do another example or another video with another example, and I'll do that. Okay, but I think one video is going to be enough. One example will be enough. And this is example 2 from your book. And I wanted to do, let me say this, I wanted to do an example from the exercises or examples in your book because, you may or may not notice if you're reviewing those examples in the book, they miss some parts, right? And that's because they expect you to know those and fill it in. And so, I don't know if I think I'm going to show everything for this example so you can sort of go back and look and compare to see what they took out, and think about that too, because that'll help you. That's another strategy that'll help you fully understand the problem. If you can fill in those gaps that they assume you already know, if you can fill it in and really understand. Okay. All right. So let's get to our problem. Solve 4y double prime plus 36y equals cosecant 3x. Okay. And before we start this problem, just for those people who have not had linear algebra, recall, and because I want to keep it simple for you all, we're just going to stick to 2x2 matrices. The book talks about higher order, but I'm not going to go there because the purpose is to make sure you understand the concept, not to do linear algebra. All right, so the determinant, remember, use our absolute value symbols represent determinant, and self-explanatory when you know the difference, right? And so to find the determinant of a 2x2 matrix, you just take A times D minus B times C. Okay, so that's all you need to remember, and you will know how to do this problem. All right, so I like to give steps when possible. So step 1 is to make sure you isolate y double prime, okay, if it's not already. And so when we do that, we're going to get y double prime plus 9y equals 1/4 cosecant 3x. Okay. Step 1, pretty straightforward, not bad, right? Step 2, find y sub c, find our complementary function. Again, this is something you all have been doing a lot of, so you should know how to do it. We find our auxiliary, and I know how to spell it now, equation. All right, which is, in this case, m squared plus 9 equals 0. And so that tells us that m equals plus or minus 3i. Okay. And you should see that. That shouldn't be any problems. So our complementary equation is c sub 1 cosine 3x plus c sub 2 sine 3x. Okay. All right, so now we need to talk about finding our particular solution, which, remember, we said it's going to be u sub 1 of x times y sub 1 of x plus u sub 2 of x times y sub 2 of x. Okay, and just for sake of convenience, let's call this y sub 1 of x, right? Because it's with the c sub 1. And let's call this y sub 2 of x, okay? As long as you're consistent, if you want to flip them, that's fine. It's just going to be more difficult to follow the notes, but you know, you can do that if you like. Step 3, Wronskian on different level. Wronskian, finding the Wronskian. Well, in this example, the Wronskian will be y sub 1 we said was cosine 3x, right? And then y sub 2 is sine of 3x. And now we just take their first derivative. So this will be negative 3 sine 3x, right? And 3 cosine 3x. All right, so that will give us 3 cosine squared 3x minus a negative 3 sine squared 3x. So that's 3 cosine squared 3x plus 3 sine squared 3x. We can factor out a 3. We get cosine squared 3x plus sine squared 3x. And that's 3 times 1, which equals 3. Okay. I'm showing you this just for notes purposes. You can just, if you see from here that your answer is going to be 3 because of the trig identities, then that's fine. Okay. All right. So next, step 4. All right, so hopefully you guys need to pause this. You can to finish writing that down and then come back to the video. Step 4 is to find. Step 4 is our last and final step before we write the general equation, but to find u sub 1 and u sub 2. I did, however, break down step 4 into 2 parts, so A and B. So in A, let's find w sub 1 and w sub 2. Okay. Well, again, looking back here or seeing your notes, w sub 1, remember we take out that first column, replace it with 0 in our f of x, and then keep the second column the same, and then vice versa for w sub 2. Okay. And so then for us, we will get, for w sub 1, we will get 0, 1/4 cosecant, 3x. And then sine 3x, 3 cosine 3x. Okay. Taking that, we will get w sub 1 should be 0 minus 1/4 times 1 over sine 3x. Okay. And I replaced that because I knew that I could factor this off. Okay. So that's why I did that. That becomes a 1. So our answer is just negative 1/4. All right, that's our w sub 1. W sub 2, we flip that. So the first column stays the same. Cosine 3x, negative 3 sine 3x. And then 0, 1/4 cosecant 3x. Okay, so here we're going to have 1/4. This is cosine 3x. And I'm going to change this too, but I want to be careful there. I'm not going to minus 0. So that's 1/4 cosine 3x over sine 3x. And I'm not going to make that cotangent 3x just because I'm keeping in the back of my mind something that I know I will be doing, which is integrating. And I would advise you can change it. It's just more complicated to remember the integral of cotangent and tangent, right? Versus doing a substitution, which I see in our future, okay? Because I wrote out the notes already. I wrote out the solution. All right. So B, find u sub 1 and u sub 2. Well, how can we do that? Well, first we need to find, doing this w sub 1 and w sub 2 helps us to recall that u sub 1 prime is equal to w sub 1 over w, right? And u sub 2 prime, maybe I should put it here. U sub 2 prime is w2 over w. Okay, so let's substitute. We know what things are. W sub 1 is negative 1/4 divided by 3, I believe. That was our, 3 was our Wronskian determinant, the main determinant, I should say. And so this will give us negative 1/12. All right, u sub 2 prime is, and actually I'm gonna put it closer, just gonna try to write everything on one page. All right, so u sub 2 prime is going to be 1/4 cosine 3x over sine 3x, right? All over 3. Well, that just simplifies to what? Cosine 3x over 12 sine 3x. All right. Now, I did that because now we need to integrate, right? To find, and again, don't worry about your constant, but we just take the integral. U sub 1 is easy, right? It's just a constant. So u sub 1 prime is just a constant. So u sub 1 is just going to be negative 112x, right? You integrate with respect to x. Okay. So we have that. We're done there. Here, so u sub 2 is the integral, and I'll do this. I'm going to move it. U sub 2 is 1/12. I'm going to pull out that constant. The integral of cosine 3x over sine 3x. This is why I said that I didn't want to change it to cotangent. Unless you know the integral of cotangent, then by all means. But usually it's nicer. We can do us a quick u substitution and then sine 3x. Make it what's in the denominator, so the numerator will pop up there in your derivative. So du is 3 cosine 3x dx, right? Divide by 3. And again, I'm doing this just for your notes' sake because this is the only problem I'm doing. And so we have du over 3 equals cosine 3x. So that's going to make it 136, right? If we multiply that 1/3 by 112, and we have 1 over u, or du over u. Okay, when we do the substitution. And if you need to fill in the gaps, go ahead, but because of space and time. Natural log of the absolute value of, and I'm going to go ahead and plug in my sine 3x again because I don't have space. If you want to put natural log of absolute value of u and then put in sine of 3x, that's fine. I know it's hard to break the habit, so if you have a plus c, that's fine. Just remember in your final answer that c is just going to go to 0. You don't need any constants. In your particular solution, you don't need any constants. You just set them equal to 0. So I think we have room. We're gonna get this final answer on this page. So our final answer, we have everything now, right? Here's our final answer. Y of x equals c1 cosine 3x. Don't forget what we started with, right? Plus c2 sine of 3x. Now be careful. Remember, I did it in this video. This is probably the last video. Remember that, yes, y sub p is u sub 1 times, right? Remember, it's u sub 1 times y sub 1 plus u sub 2 times y sub 2, all right? You just can't write u's by itself. Don't forget times y sub 1 and y sub 2. So getting back to our final answer, y of x equals c sub 1 cosine 3x plus c sub 2 sine 3x minus 1/12x cosine 3x times cosine 3x, that's y sub 1, plus 1 over 36 natural log of the absolute value of sine 3x times sine of 3x. And in under 15 minutes, if I silence now, we'll be under 15 minutes and we are done with the notes. So I'll see you all in class.